before Facebook, before Python, before the first personal computer, there was a single algorithm, handwritten in the margins of a paper, for a machine that didn't even exist yet. And it wasn't written by a man. It was written by a woman in 1843. This wasn't science fiction. It was software before there were even computers. Today, we live in a world of apps, code, and automation. Software runs everything, from your phone's notifications to the systems controlling power grids, airplanes, and hospitals. But for something so central to modern life, its origin is surprisingly murky. Who wrote the first code? Who imagined instructing a machine to carry out tasks? And how did we go from a hand-drawn algorithm to entire empires built on lines of code? Unlike hardware, which is big, visible, and has clear milestones, software is invisible. It leaves no physical trace. It's logic written in symbols, executed in silence. Ask someone who invented software, and you'll hear names like Gates or Jobs. But they didn't create software, they commercialized it. Even Alan Turing, often called the father of computer science, didn't write the first true program. That honor belongs to someone whose name was almost lost to history. And here's the problem: software didn't start in a lab. It started in imagination. And for a long time, the people writing the code weren't even recognized as engineers. Ada Lovelace, the prophet of code. Nearly 2 centuries ago, Ada Lovelace, daughter of the poet Lord Byron, collaborated with mathematician Charles Babbage on his unfinished masterpiece, the analytical engine. This was the 1830s. Steam powered everything. Electricity wasn't in wide use. And yet Ada saw further than anyone else. She realized that the machine could manipulate symbols as well as numbers. She wrote that it could compose music, weave patterns, anything that followed rules. This was a profound leap. She wasn't just describing maths. She was describing software. In 1843, she translated an academic paper on the analytical engine and added a set of notes longer than the paper itself. In one of these notes, Note G, she described an algorithm, a step-by-step method for calculating a sequence of numbers. That's now considered the first published computer program. Ada Lovelace imagined modern computing before computers even existed. The women who programmed Unity. Let's fast forward a century to the 1940s. The United States is at war. The army needs a machine to calculate ballistic trajectories, fast. So it builds an electronic numerical integrator and computer, the world's first general-purpose, fully electronic computer. But here's what's less well known. The software for electronic numerical integrator and computer was written entirely by 6 women. Kay McNulty, Betty Jennings, Betty Snyder, Marlon Westkoff, Fran Bilas, and Ruth Teitelbaum. They were hired as computers, human calculators. When the electronic numerical integrator and computer was ready, the task of making it work fell to them. They had no manuals, no programming languages. They wrote code by manipulating switches and rewiring circuits. They debugged with logic, maths, and sheer intuition. At the machine's unveiling in 1946, the engineers who built the hardware were celebrated. The women were not even introduced. For decades, their names were lost to history. But make no mistake, the electronic numerical integrator and computer women were the first software engineers in the modern sense. From machine code to programming languages. In the early days, programming meant physically rewiring a machine or feeding it a stack of punch cards. It was tedious, error-prone, and only a handful of people could do it. Then came an idea that changed everything: abstraction. Instead of talking to the machine in ones and zeros, what if we could write instructions in something closer to human language? Enter Grace Hopper, a naval officer and computing visionary. She believed programming should be accessible. In 1952, she developed the first compiler, a tool that translated human-readable commands into machine code. This paved the way for programming languages like COBOL, which she also helped create. Now, software could be written, tested, and improved without touching a wire. It was the beginning of software as an independent force, separate from hardware. Software becomes industry. As computers moved from labs to businesses, software became a product. Initially, it was bundled. When you bought a machine, the software came free. But by the late 1960s, IBM made a pivotal decision to unbundle software from hardware, effectively inventing the software industry. This opened the door to startups, licensing models, and eventually billion-dollar empires. But it also raised new questions. Can software be owned? Can it be patented? In the 1980s and 1990s, court cases and controversies erupted, especially as open-source developers pushed back against corporate control. The idea that anyone could write and share software freely became a movement and helped fuel the internet as we know it. If we were to pinpoint the moment software changed the world, it might be this: the day Grace Hopper's compiler ran successfully. Because at that moment, computers became accessible to more than just hardware experts. They became tools of thought. Software became scalable. It could now evolve, replicate, improve, without needing to rebuild the machine itself. And that changed everything. The history of software isn't a story of machines. It's a story of ideas, the logic, of people who saw the potential in pattern and process. Ada Lovelace, the electronic numerical integrator and computer 6. Grace Hopper. They didn't just write code. They built the foundations for how we interact with machines today. Their work made it possible for programmers, artists, scientists, and even content creators to command a digital world with words. And in many cases, they did it without recognition. But today, we remember them, not just as pioneers of computing, but as the architects of a revolution. So, who do you think was the first true software engineer? Was it Ada with her prophetic code? Grace with her compiler? Or the electronic numerical integrator and computer women debugging in silence? Tell us what you think in the comments.